In this video, we're going to look at stationary points of curves. What is a stationary point? Well, it occurs when the derivative dy by dx is equal to 0. That is, the tangent to the curve at that point is parallel to the x-axis. Such a point is called stationary because at that point the function isn't increasing or decreasing. We can see three such points in this diagram, one of each kind. There are maximum stationary points, where, at least in that local area of the graph, the function takes a maximum value, minimum stationary points, where the function takes a minimum value in that area of the graph, and points which are neither maximum or minimum points. These are called points of inflection. If we're given a function, but we don't know what the graph of that function looks like, we know we can find all the stationary points by finding the x values which make up the derivative 0. But how can we tell the difference between maximum points, minimum points, and points of inflection? Well, a good tool is the second derivative test. It says that if the second derivative of y with respect to x is less than 0, then we have a maximum point. If d2y by dx squared is greater than 0, then we have a minimum point. But if d2y by dx squared is 0, then unfortunately we can't tell which type of point we have. Let's try the following example. We're asked to find the stationary points of 4x cubed minus 6x squared minus 72x plus 1. And can we find what type of stationary points they are? Well, let's start with y is 4x cubed minus 6x squared minus 72x plus 1. Then dy by dx is 12x squared minus 12x minus 72. This tells us that d2y by dx squared is 24x minus 12. Now, going back to the first derivative for a moment, we can simplify its expression to 12 times x minus 3 times x plus 2. So, dy by dx equals 0 when x equals 3 or when x equals minus 2. Now, at x equals 3 say, d2y by dx squared is 24 times 3 minus 12, which is certainly positive. And when x equals minus 2, d2y by dx squared is 24 times minus 2 minus 12, which is certainly a negative number. So, from the second derivative test, this means that we have a maximum at x equals minus 2 and a minimum at x equals 3. In this case, we were able to calculate both stationary points of the curve and also what type they were.